All right. So what we're going to do today is we're going to finish up section 3 of chapter 3. There is a section 4 in chapter 3, talks about scatter plots, but we're going to leave that for a later lesson when we talk about regression. So we'll get back to 3.4 a little bit later. And so we're going to, after 3.3, after I complete that today, I'm going to jump right into chapter 4. And so I guess we should get started. All right. And I'll show you where we left off also. As people start coming in. All right. So let's share PowerPoint for that. All right. And in this section, we were talking about histograms. Histograms are important graphs for numerical data. And let's see, I think we were going through this section, this set of slides last time, looking at frequency distributions and histograms for continuous numeric data. And now, when what we do basically is we take the numeric data and break them up into classes. In other words, we group the data. So if the data runs from, let's say, 10 to 100, all your data points run from 10 to 100, we may consider breaking them up into 5 classes. So, and each class might be maybe 15 or 20 units across. So the width of each class would be something like that. And then we want to make sure that every class includes each of the data points in the data set. What we're basically doing is counting the number of data points in the data set that are in each class. So I was giving an example last time. Let me see if there's anything here in the slides here, which shows an example of creating one of these. All right. So here's an example here where we have a study, and what was being measured was sleep deficit. All right. And sleep deficit was just defined as a difference in the amount of sleep you're getting on weekends as opposed to on weeknights. All right. So, for example, if you typically slept 9 hours on weekends and only 7 hours during the week, your sleep deficit would be 2 hours. So basically, it's the number of hours that you sleep during the weekends each night minus the number of hours each night you sleep during the week. So sleep deficit means that you're getting less sleep during the week each night. I think that makes sense. And remember, a negative means that you're actually sleeping more during the week than you are on the weekends, which is unusual, but some people do. And then what we did was we took all the data points, all the answers that people gave, and we categorized the sleep deficits going. So anyone that slept from -6 hours up to, but not including -4 hours, are in this first class. And anyone who slept, it is a sleep deficit. So basically, the sleep deficit for a person is between -6 and -4 hours. Then they go into category 1. If their sleep deficits between -4 and -2, they go into category 2. All right, so you see how it works? And we just count the number of people who have answers that are in these ranges here. Now in this chart here, they only calculate the relative frequency, which means it's the number of people in each of the categories divided by the total number of people in the study. And so that's how they came up with these relative frequencies. Now they grouped them into 2 groups, which, so some people started the morning, let's say Yeah. So some people started their day in the morning. Some people started the day in the afternoon. Regardless, that's how you calculate you calculate frequencies. You just count the number of people in each of these categories. Now, let me give you my own example. All right. This chart here is called in this case, a relative frequency distribution table. All right. And I'm going to show you one with an example. All right. So this is just in the slides itself. But once the way they do it here, once they show you or display the table, then they can actually display the histograms. The histograms are just a picture of those tables. All right. So along the y-axis here are the relative frequencies. Along the x-axis are each of the categories, not categories, each of the classes. So from -6 to -4, from -4 to -2, going all the way across. Now they have 7 categories here. If you go back one, you'll see 1, 2, 3, 4, 5, 6, 7. And so they should have 7 categories for each of these groups. And so basically the height of each of the rectangles is the relative frequency for that class, right? Relative frequency is like a percentage. So that's how they come up with these heights, is from these relative frequencies. So for example, the number of the percentage of these people in the study who stated that they had a sleep deficit anywhere from 0 up to 2, there's 44.2% of all the people in the study answered with a number between 0 and 2. Now, the way you read this chart is 0 up to, but not including 2. So if somebody answered 2, it would be in the next class here, from 2 up to, but not including 4. All right, so that's how they deal with the boundaries here. The 2 is not included in this class, it's included in this class. All right, so what we did last time, we did it before we left, we did an example. So I'm going to show you that example. And hopefully the example will make it clear how we do this and how we can do it with our calculator. All right, so we're going to go to the Cengage ebook. This is the example I showed you last time. The data in here, that there's actually 45 data points. And what are the data points? It's the annual maximum wind speed in Hong Kong for each year over a 45-year period. So for each year for 45 years, we have the annual maximum wind speed, right, outside wind speed in meters per second in Hong Kong. And these are the answers for all 4 of those 45 years. So what we want to do is we want to create a frequency distribution of all these numbers. Now, all the numbers are different. I don't think there's any that repeat. If there are, there's very few of them. And what we're going to do is what I want to do here is I want to create a frequency distribution chart with 6 categories, or not 6 categories, 6 classes. All right, 6 classes. So how do I do that using your calculator? Now, if you didn't want to use your calculator for this, if you wanted to do it manually, what you would have to do is, number one, if you decided you wanted 6 classes, you'd have to look for the smallest number in the data set and the largest number in the data set, and that's what you would do, right? And then the whole idea is you want to find the width of each of these classes. How wide are the intervals for each class? And you want each of the intervals to be of the same width or the same length. So the way to calculate that is you take your largest number in the data set and subtract the smallest number. And we'll learn a little bit later today, that's called the range. And then we divide by the number of classes we want in our frequency distribution chart. So I'm picking 6 in this example. You could pick 5 or 7, depending on the situation. I will, in this course, I will always give you the number of classes. So it's not, it's not something you would just make up on your own in this class, but you could if you were doing this, on your own, if you wanted to do it. All right, now in this problem, they're asking you to create a histogram, right? They want you to construct one, but they're not telling you how to do it. But I'm going to tell you how to do it because your calculator has a certain way of doing this, creating a histogram. And so the way I'm going to show you is the way I want you to do it when you do it in a test. The examples I give you will also be done exactly the same way. And the reason is because your TI-8384 calculator does it in this particular way. There's alternate ways of doing it, but I'm just going to show you this one way. All right, so what do we do first? Well, I think last time what I asked you to do was enter all 45 numbers into your calculator. And I think all of you, if you were here, you did it. And if you watched the video, you probably did it also. So we'll go back to our calculator and show you what it's coming up with. Now, let's just go out of the screen here. And actually, I'll go back to the main screen. Now, main screen, you just hit second and quit. Actually didn't work. Let's try it again. Second. There we go. So you get a blank screen when you hit second and hit this mode button here. And to get it to any of the statistical features of your calculator, including putting the values of a variable into a list, we're going to call them lists. We're going to hit the stat button. Now, don't hit second stat where it says list above, because that's actually a way of creating lists. You don't want to create, your calculator comes with 6 lists. Typically, that's enough. If you wanted to have more on your calculator, you can do that by hitting second stat, but we're just going to hit the stat button. We get to this screen here. And if we want to enter data into our calculator for a variable, for one variable or multiple variables, sometimes we'll have multiple variables, we're going to hit enter where it says edit up here. So there's an edit on the top and there's an edit below. One other feature I want to show you before I hit the edit button here is that option number 4 is, it says CLR list. This is a way of clearing a list of numbers in your calculator. So if you have a list of numbers that you've entered, and then you turn your calculator off, when you turn it on again, those numbers reappear in those lists. So if you want to clear a list, you would do something like, you would hit this, you hit 4, you choose option 4 here, and then you would simply type in the list number of the ones that you want to clear, and then hit enter. Now, how do you do the list numbers? Well, let's say you wanted to clear list number 2, and I know right now it's blank in my calculator, so it's safe for me to clear it. I would hit second 2. Second 2 produces L2, that's list 2. You can see above each of the numbers on your calculator, that in blue, there are list numbers. So so basically your calculator has mentioned 6 of them, from L1 up to L6. So if you want to clear a list, you just type in second. Let's say you wanted to clear L2 and L3. Well, first of all, you would put a comma here, and then you would put second 3. Let's say you wanted to clear those 2 lists, you would hit enter, and it says done. And then once you go back into where the lists are, you would find that those lists are now free of any numbers. That's the way to clear your calculator of any list. All right, now let's go back to hit the stat button again. And we're going to hit enter because we want to go to where edit is, because that's where our lists are. And last time I had asked you to enter all 45 of the answers, all the 45 values from that study, right? The average wind speed for those 45 years in Hong Kong, and I listed all 45 of those numbers. This is one variable. Every time we have one variable, we would enter all the numbers under one of the lists. So L1 is one variable. If we had another variable, we would enter it under L2, like that, okay? And notice at the bottom of the screen here, just above these gray buttons, it says L1 and in parentheses 1 is equal to 30.3. Well, that's because what's being highlighted now is the very first number in this data set that you entered. That's the first observation of this variable. It's 30.3. If we scroll down to the next one, notice it now it's highlighting the second number, and it says L1 in parentheses 2. So in list 1, observation number 2 is 27.2, and so forth. You just click down until you get to the very last one. All right, and if you go all the way to the bottom, you should get to number 45. All right, the 45th number in the data set. Notice it's continuing to go because I will stop in a minute. There we go. Stop on the 30th one. The 30th number that I entered was number 41. All right, so we're going to go back to the top. Top of the data set. And it keeps going because I've clicked it many times. Oops, what happened there? Oh, notice that it's if I click it too many times, it starts from the bottom and starts going up again. So actually, I'm gonna. There we go. Now I'm back to the top. One way of getting to the top is go one more from the bottom. Now, one of the features of your calculator that I may use in this course, I want to show you right now, and maybe you've never seen this before, is if I click one up from the first value in the data set, notice that L1 has in the brackets here, it has all the values in the data set. I go to up to L1. What I can do from this position up here is I can do formulas. And I'll show you how that works. For example, if I wanted to, let's go to L2. Notice I'm now in this L2 region up here. And it says L2 is equal to. What if I wanted L2 to be equal to 2 times L1? In other words, I wanted to double every value in L1. So what can I do? I can do L2 is equal to 2 times, and then I'm going to do second 1. I've created a formula where I'm telling the calculator that in L2, I want to take all the values in L1 and double those values. So what I'm going to do is hit enter, and automatically I've doubled every number in L1 and it produced it in the same order in L2. And I think it's a pretty cool feature, right? Very cool feature. Another thing that I can do is I can sort numbers in a data set. Now, if I'm going to sort a data set from the smallest to the largest or from the largest to the smallest, I would keep the original data set in the unordered way that you entered it originally, so that in that way, if you make any mistakes, you can always go back to there. Suppose in L3, I want to, let's just go to L3 now. One way to get to L3 is I'm just going to click my right arrow button, taking me to the first observation in L3, but if I want to create a formula, I would go up 1. But let's say, I'm not even going to do it from here. Let's say I wanted to sort the values in L1, and I want to sort them in L3. One thing I can do is copy everything from L1 and L3, and then I'll sort it. And I'll show you how to do that. So let's say I'm going to scroll back up. Again, I can create formulas from there. And suppose I just want to copy all the numbers from L1 into L3. I'm going to just say L3 is equal to second 1, L1, hit enter. Now I've copied everything from L1 to L3. Now suppose I want to sort everything in L3, from the smallest to largest, what I'm going to do is hit the Stat button. And notice that you have two options here, option 2 and 3 for sorting. Sort A means sort ascending, which means from smallest to largest. Sort D means sort descending from largest to smallest. I have never used it, option 3. I've used option 2. So I'm going to choose option 2. I can just scroll down and hit enter. Now what it's looking for is a list to sort from smallest to largest. So I'm going to put L3 in here. So I'm going to type in second 3. Notice that it opened a set of parentheses, so I'm going to close the set of parentheses, which are on this row here, on the calculator. I'll hit enter. As it's done, and now I'm going to go back to Stat, hit enter, and you will see in list 3 is the sorted version from the smallest to largest of L1, and it's in L3. So now in L3, I have that same data set sorted from smallest to largest. Now, the question is, why would I want to do this? Well, suppose I wanted to determine something like a percentile, which we'll learn later. That is the number of values that are, maybe we want the smallest 20% of the values in your data set. So it would be helpful to have the data set ordered from smallest to largest so that you could find that value where 20% is less than that number. So that's one reason why we may want to sort. All right. But anyway, I just wanted to show you those features. You can do all sorts of fancy formulas using values in a data set. All right. And but that's not something we'll do necessarily today. I just wanted to show that to you. All right. So any questions about how to create formulas in calculators, how to enter numbers into a calculator? Again, it's all using the Stat button. All right. That's why we need the TI-8384 calculator, because this is the easiest calculator to do all of this stuff, and it's comprehensive. It does a great many types of calculations for you. All right. Now that we have, we don't have to use L2 or L3 here, but we're going to just leave it for the time being. We're going to use L1 for everything we're going to be doing. If we're going to use our calculator to create a frequency distribution histogram and also a table, and we want to use our calculator to do it, one way of doing this is, again, enter all the numbers into a list. It doesn't have to be in any order. Just make sure all the numbers are listed correctly. And then I think what I did last time was I determined what was the smallest and largest numbers in the data set. Now, one way of doing this is I'm going to hit the Stat button again. You can always go back to Stat, beginning, and I'm going to scroll over with my right arrow button here and to go to Calc. And the very first option is one var stats. This means one variable statistics. These are statistics that are calculated for you for a data set. So I'm going to hit enter. And it's asking me which list or which variable I want to calculate statistics for. So I'm going to pick L1. And I'm just going to scroll down, and it says calculate here. Whenever it says calculate in any of these features here, you're going to hit enter. And notice what it does for this data set that we just calculated. I'm going to show you actually a little bit more from here, because this is some of the information I wanted to bring out today in chapter 4, beginning of chapter 4. So one of the things we're going to be talking about is the mean, which is the average. What is an average? We just add all the numbers in the data set, divide by the number of numbers in the data set. I think every one of you should know what an average is, all right? I'd be surprised if you didn't. But it does it for you, and that's what this X with a bar above it means. And actually, we actually say X bar. Now, X bar is a sample mean. Remember the difference between a sample and a population. A sample, we're drawing a subset of the population. to make a study, all right, to do some sort of study, observational study, experimental study, whatever. If we have a sample, we use X bar to be the symbol for the mean, the simple mean. We just add all the numbers up and we divide by the number of values in the data set. Now, to make this even easier, this calculator goes to great lengths to give you more information that you need. This second line here, the symbol with this looks like a weird symbol here. It looks like an E almost, but it's not. It's actually a Greek symbol. The second symbol here next to the X, to the left of the X. So this is called sigma. This sigma here is a capital sigma, capital. The Greek letters have both capital letters and small letters, just like our language does. And you'll also be told a little bit further down here, there is a small sigma, but this is sigma, so we call it sigma x. And the sigma means add. All right, so when it says sigma x, now x refers to what? The variable, all right? X is referring to the values for the variable. So when it says sigma x here with the big sigma symbol here, it's telling you to add up all the numbers. So if we added up all 45 numbers in your data set, it would come up to a total of 1,749.5. Okay? And that's what that symbol means. Now, a little bit further down, you see n, small n, is equal to 45. The symbol small n means sample size. What is a sample size? The number of values in your data set. All right, there's 45 numbers in your data set. That means there are 45 years that we measured the wind speed, average wind speed. So 45 is the number of values in your data set. If we took 1,749.5 and divided by 45, we would get 38.877777. Seven's go on forever. All right. So that's how they come up with the mean. You add up all the numbers, 1749.5, divide by 45, and it actually does the calculation for you. All right. Everybody clear about that? So this is the second number here is the sum of all the numbers. The third number here, we don't use very much anymore because this calculator does many of the calculations for you. It used to be that we would need this calculation, the 72,595 number here. What this number is if we took each number in the data set and squared that number, each number in the data set and squared each of those numbers, and then added up those squared numbers, we would get the 72,595.65. Okay. The fourth number is what's called the standard deviation. I'm going to talk a little bit about, if I don't get to it today, I'll get to it next time. The standard deviation is the measure of how spread out the data is. It's sort of like the average spread. There are actually two standard deviations that are calculated here, and I'll mention to you why later when I actually go through what the formula looks like. The standard deviation, if it's a sample, is 10.201. And this second one here, here's another Greek symbol. This is the small sigma. Small sigma. It's a sigma x here, but this symbol here is also sigma, but it's a small one. This means a population standard deviation. And it's a different number, and there's a reason for it, but that's what it means, population standard deviation. Now, you may ask, why isn't there a symbol for the population mean? I mentioned X bar up on the top here is the sample mean. And that's because the population mean and the sample mean are calculated exactly the same way. So the Texas Instruments decided just to list one of those symbols. And there is a symbol for the population mean, which will be shown to you in chapter 4, and it's called mu. And you'll see the mu symbol a little bit later, but that's for the population mean. All right. So you'll get used to these symbols as we use them more and more. I'm just introducing to you those now. Now, what's on the bottom of the, and notice that there is a arrow pointing down here next to this Q1. It just means there are more things below. So if you use your bottom arrow key, it'll just take you to the bottom of all those numbers. Now, we just got to the bottom. And so below the population standard deviation and the sample size, the n, we have minimum. That's the smallest number in the data set. So as you can see, it gives you that smallest number. If we had hundreds of numbers in your data set, you wouldn't want to have to search for the smallest number. You could just go to one variable statistics and it gives you the smallest number in the data set. Also the largest number, it says max x. The largest number is 64. The numbers that are in the middle here, I will talk about those probably next time. Q1 is what's called the first quartile. It means 25% of the numbers are below this 31.7. MED is the median. That means 50% of the numbers are below that. Sometimes that is called Q2. Some books call it Q2. But it means 50% is less than that. Q3, 41.65, is the third quartile. It means 75% of the numbers in a data set are below that number. All right. And we use these 5 numbers here from the minimum all the way up to the maximum, these 5 numbers here, in creating a special type of graph called a box plot, which I will show to you next time. All right, box plot. It's another way of displaying data in a data set. So much of what I just showed you we'll be using in this course. This is a very useful screen. If you did not have a calculator with you when you were taking a test, you could calculate all these things. There's formulas in the book that show you how to calculate them. But it's preferable to have your calculator all ready to go. And by the way, it may sound obvious to you, but it's very important that when you take a quiz or a test, that make sure that the calculator's batteries, if there are batteries in your calculator, are good to go. Or if you have a calculator where you plug it into the wall to charge it, make sure it's fully charged. People who've taken tests before where they run out of charge in their calculator in the middle of the test. That's not an excuse, by the way, for stopping the test. You need to continue. So you have to make sure your calculator is all ready to go. You just have to make sure of that when you're taking your tests. All right. Anyway, that's the one variable statistics. And again, to get there, you hit stat, scroll over to calc, and hit enter. And then you now it all automatically, the list that you're calculating all these statistics for is automatically defaulting to L1. If your data is in another list, you just simply retype it. So if it's an L2, you would hit second 2, and it would just simply change to L2. All right. Any questions? All right. So now let's go back to this idea of creating a histogram and a frequency distribution chart. Now, one of the things we wanted to do, actually, let's go back. I should go back to the one variable statistics. Oops, that's not what I want. All right. So again, forget about L2 and L3 for now. And maybe what I should do is maybe delete what's in L2 and L3. Yeah, let's go ahead and do that. I'm going to go stat. I'm going to do clear list. Scroll down to 4. Enter. Oops. One thing you could do is just type in 4. And I want to delete what's in all the numbers in L2 and L3. So I'm going to hit second 2, comma, second 3. Enter. Done. All right, let's go back to make sure it's been cleared. Yep, as you can see, I just have the data in L1. All right, now I want to go back to one variable statistics because I want to look up again the smallest and largest numbers in the data set. And once again, the smallest number is 25.7. The largest number is 64. If I want to calculate, and the book shows you how to do this, I want to calculate if I want 6 classes for my frequency distribution table and for my histogram, which means 6 rectangles. What I do is I take the largest number in the data set, the 64, I subtract the smallest number, 25.7, and I divide by the number of classes that I want, or rectangles that I want. All right, the way to do this, so it's 64 minus 25.7. I'm going to open up a set of parentheses here. 64, I'm going to type in 64 minus 25.7. Those parentheses divide by 6, enter, and I get 6.38 and a whole bunch of 3s after that. Now, all the numbers in the data set are 1 decimal place long. All right, there's 1 decimal point for each of the numbers in your data set. So what this number is going to end up representing is the width of each of the classes, how wide the classes are going to be. But I want to round it up to the nearest digit that is the same for all the numbers in the data set. Since each digit is 1 decimal point long, I'm going to round this up to the nearest. When I say round up, I mean don't use rounding, just go up to the next 1 decimal point, and that is, I'm going to round up to 6.4. All right, so if there's any numbers, it doesn't even matter if there's numbers after this, I just go up to the next decimal point, 6.4. If there were all whole numbers in the data set, I would just round up to the next whole number. Now, it'll become clear in a minute why we would want to round up. It has something to do with making sure that when we count the number of values in a data set for each of the classes, we end up including that largest value in the data set. We don't miss that one. So I'm going to round up, and I'm going to say this is 6.4 is the width of each of the classes in the data set. Now, this is the little trick that you're going to be doing with your calculator. You're going to go up to what's called window. Window is in your calculator. I don't know if you've ever played with the window feature, but it basically, if you're going to be graphing, doing any type of graphing, it basically will tell you which values are going to show up on your graph. I'm going to click window here. Now, right now, I've entered all the numbers I want, but your calculator should show, if you haven't done it anything like I did last time, it should show -10 for the x minimum, +10 for x maximum, then 1 for x scale, that's SCL, and then for the y minimum should show -10, y maximum should +10, and it should be 1 for the y scale. What I've done here is I've entered different numbers in here because I wanted to make sure that when I create my histogram, you can actually see it on your calculator. So it starts off at 25.7. Anybody remember what that number is? 25.7 is what? With reference to your data set. That's what? I'm sorry?
That was the lowest number. The
lowest number. That's the smallest number in your data set. So that's what you're going to put into your window here, the smallest number in your data set for the x's. Because remember, when you do your histogram, the x's are your variable. What for the y, for the x maximum, I want to pick a number that's bigger than the biggest number in your data set. Remember, the biggest number in your data set is 64. If you wanted to, you could pick 65, but I just went up by 1.1. I just picked something a little bit bigger than 64. And again, I'm doing that to make sure that the value 64 is included in that very last class, because 64 is the largest number in your data set. So I'm just giving you a recommendation here. Pick a number that's bigger than the largest number in the data set, but not much bigger, just a little bit bigger, to make sure that we count that largest number. Now, notice what is in under X, next to X scale. That is that 6.4 that we just calculated. It's the width of each class, and that's important to have that in this position here in your window. The X scale is that class width. We call it class width. Now, for Y, the Y's, remember, are going to be frequencies. So the smallest frequency is always 0. So the Y minimum is always 0. The Y maximum, well, there are 45 numbers in your data set. Obviously, the Y maximum could be up to 45, but I picked 20. If you pick a number that's too small, you'll notice that when you create your histogram, the top of a one of those rectangles gets cut off. And if that happens, go back into here and just increase what the Y maximum is. But the Y maximum gives you the biggest height, the biggest frequency for each of those classes. And again, you may not know that ahead of time. You just play with that number until you get a number that's big enough so that you can see the top of each of the rectangles. If you go down here, you can see, I can see the top of all the rectangles here. What if I change, I'm going to show you something here. What if I change this to 10 here? You see what happens over here? Now, you won't see this with your calculator, by the way. This is a display for teaching. But notice what happens when I put 10 for the Y maximum. Notice the first two rectangles get cut off on the top. You don't see the top horizontal bar on the rectangles here. So if I go up, let's say if I made that 15 here, and oh, there we go. And notice it doesn't get cut off anymore. So 15 seems to work. I had originally put 20 in there, but so you won't see this screen here, this where it says the table here, you're not going to see that when you're working with your calculator. So the only way to know is that you create your histogram and then you have to go back to the window if your rectangles get cut off. Y scale, leave it as 1. It's typically good enough. All right, now what's the next step? Your window is set up so that you'll be able to see your histogram. What you're going to do is you're going to go to where you can plot a histogram. Now, if you remember, if you've used this calculator before for algebra, or maybe pre-calculus if you took that course, the Y equal to is where you would enter your equations. Now, one of the things I would want to make sure is that if you go to Y is equal to, if I go into it right now, everything is blank here. Please, please do not have any equations in here. If you have equations in here, you're not going to be able to plot your histogram. So everything has to be deleted in this screen here, your Y is equal to screen, which we're not using it in this course. What we're going to use is second, we're going to hit our second button, and then the Y is equal to, and we're going to use what's called stat plot. So they give you several of these stat plots. Typically, you only need the first one. So just hit enter on the first one. Now, your screen should show something like this. All right. In other words, it's blinking next on the on, but what's highlighted is off. What you want to do is hit enter where the on is. So now you've turned on the stat plot. All right. Then you hit your arrow button going down to get to type. Now, depending on whether you have an 83 or 84 calculator, what you're looking for is the very first one is going to be the one that's highlighted here. And that's a scatter plot. You don't want that one. What you want is where it has the rectangles. That's the histogram. So go to that one, scroll over with your arrows and hit enter. All right, so you're highlighting your histogram and then you go down again using your bottom arrow, and then you put the list value in here, the list that where your data is. Now, if it's an L2, you would hit second 2 or L3, second 3. It defaults to L1. Now, you can even, with some calculators, you have a color feature where you can, your histogram will be in color. And I know the 83s, I don't think have that feature. It doesn't matter, all right? I don't even bother with that. But anyway, once you're done with this and you have the right list and you've chosen your histogram, you've turned it on, you can go to graph. You can actually hit the graph button here. And this gives you the histogram. All right. Now, you might look at it and say, all right, I'm looking at the histogram. It's not giving me any numbers. I don't even know what I'm looking at, right? There's no numbers there. Well, where do the numbers show up? And this is the part that I think the calculator got stuck with last time. I hope it works this time because I got stuck again when I was playing with this before class, and I finally got it to work. I think it's going to work this time. Now hit the trace button. See the button right next to graph, trace? There we go. So this is where the numbers show up. All right, now notice there are 6 rectangles for each class. There's class number 1. Each rectangle represents the class. The one on the left is class 1. The next one is class 2, class 3, class 4, class 5, and class 6. And what is great about this calculator, it gives you the endpoints for each class. Notice that for class number 1, down at the bottom here, it shows you that the minimum, which is on the left here, is 25.7. And then it says the maximum for that class is less than 32.1. All right. Now, if there happens to be a number in your data set, it's 32.1, it would not be included in this class. 25.7 is, it's included in class 1, but if there was a number 32.1, it would be included in the next class. Now, how many numbers in your data set are between 25.7 and up to, but not including 32.1? Look at the n equal to. There's 14 numbers in your data set. Notice it does this automatically without you having to scan your data set and count them. Isn't this a great feature? It saves so much time. Then to get to the second class, just hit your right arrow button. And now it's highlighting the second one. Notice it's blinking on the top of the second one here. And that one runs from 32.1. So again, 32.1 is, if it's in your data set, it would be included in class 2. And this class goes from 32.1 all the way up to, but not including 38.5. And there are 13 numbers in your data set. So the height, so basically, let's just go back to the first class. The height here is 14. Right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. If you wanted to count, you could, or you could just simply look and say, oh, 14. That gives you the notches there. All right. Second one has 13 numbers in the data set. There are 13 numbers in that in that class. Class number 2, 13. Class number 3 has 9. Class number 4 has 2. Class number 5 has 3. And class number 6 has 4. Each of the classes, it gives you the endpoints for each of the classes. Okay. Any questions about that? So how do you, notice what it does, it gives you the histogram. If I'm asking for a frequency distribution chart or table, you can easily create one from this by simply starting with the very first class. You would write down the class runs from 25.7 up to 32.1, and then the frequency is 14. So you would write it that way, and you do the second thing for the second class, the third class, the fourth class, the fifth class, and the sixth class. So in many textbooks, they tell you to create the frequency distribution chart first, and then you can create your histogram from that. What the calculator is having you do is you create your histogram first, and then you can create your frequency distribution table from that. So this is how you create a histogram using your calculator. It's very cool. If you don't want to do it, nobody's going to force you to do it this way. You can do it the old-fashioned way. You can simply, and I'll show you the old-fashioned way, all right? But any questions about using your calculator for this? Again, you'll have this video to look at again, right? You can just look at it as many times as you want. And of course, I will give you homework. I'll give you a couple examples to work with to help you practice this, obviously. All right. All right, so that is how to do it with your calculator. So I'm going to actually stop sharing the screen, and I have a PDF that I created for this problem. So I'm going to show you the PDF. Same problem. So notice what I did here is I created my table. Now, you can create the table from the histogram with your calculator, or if you want to, you could do this manually. How would you do it manually? Well, you start with the smallest number in your data set, and you add to that number what number? You add to it the width of the class. Remember the width of the class was? Anybody remember? It was 6.4, right? 6.4. So if you add 6.4 to 25.7, what do you get? 32.1. What do you get? So that's the beginning of class 2. You add 6.4 again, what do you get? 38.5. Add 6.4 again, what do you get? 44.9. You see how it works? You keep adding the class width until you get all 6, the beginning of all 6 classes. Now, the way I've done it here is I have I say 25.7 to 32.1, but I mean, in this case, up to but not including 32.1, because 32.1, if it is in your data set, would be in class number 2. And the same thing for 38.5. If you have to happen to have that in your data set, that would go into class number 3. So the beginning of each class is included in each class. The end is not. The end is going to be the beginning of the next class. All right. So here are the 6 classes. That's how you create them manually if you wanted to. And then how do you come up with the frequencies? You simply go manually scan the numbers in your data set. Now, what I would do is sort. Remember I showed you how to sort? You would sort the data set in your calculator. Like I said, copy it over and then sort. And then counting is easy, right? Counting is easy. You just go down and you count them for each of these classes. So there's 14 numbers in your data set that are between 25.7 and 32.1. Just count them. Count the number between 32.1 and 38.5. So you don't even have to scan necessarily. Just enter the numbers in the order that were given and then sort them, and then simply count the numbers in each of these classes. The total counts, the total of all these counts have to be the total number of values in your data set. You add 14 plus 13 plus 9 plus 2 plus 3 plus 4, there's 45. And that way you ensure that all 45 numbers are included in the histogram or included in this chart. Now, what is relative frequency? It's simply each of the frequencies divided by 45 in this case, the total number of values in your data set. So 14 divided by 45, if you use your calculator and do it, comes out to 0.3111. There's a bunch of ones after that, but I'm rounding everything to 4 decimal places here, all right? Rounding the 4 decimal places because it seems to work. 13 divided by 45 is 0.2889. 9 divided by 45 happens to be 1 divided by 5, or 0.2. 2 divided by 45 is 0.0444. 3 divided by 45, 0.0667. If you round to 4 decimal places, 4 divided by 45 is 0.0889, rounding to 4 decimal places. These are the relative frequencies. When we add all these 6 relative frequencies, they have to add up to 1. If they don't, if it's 0.9999 or 0.1 or it's 1.0001, it's a rounding error. All right. In this case, there's no rounding error. It simply adds up simply to 1. And what does 1 represent? 100%, right? 100%. Each of these relative frequencies can be expressed as percentages if we just simply multiply by 100. So 0.3111 is 31.11%. What are we saying? 31.11% of the numbers in your data set happen to be in class number 1. 28.89% of the numbers in your data set are in class 2, like that. You can also create, and this is also in section 3.3, what are called cumulative relative frequencies. Cumulative relative frequencies. What does that mean? That means that we are doing a running total of the relative frequencies, and we're adding in the relative frequencies previous to the we're adding in the previous relative frequencies from the classes before it. So class number 1, there's no smaller class than class number 1. So its cumulative relative frequency and its relative frequency are equal to each other. For class number 2, our relative frequency is 0.2889, but our cumulative relative frequency is going to be what? It's going to be 0.3. It's going to be the relative frequency of class 1 plus the relative frequency of class 2. So 0.6000. Now, what does this 0.6000 mean? It means 60% of the numbers in your data set are going to be less than 38.5. Does that make sense? It includes all the numbers in class 1, all the numbers in class 2. We're accumulating all those numbers, all right? So we're saying 60% of the numbers are less than 38.5. How about the cumulative relative frequency for class 3? Well, 20% is the relative frequency for class 2. We know that cumulative relative frequency for the first 2 classes is 0.6. We add those 2 numbers up, we get 0.8. This means now that 80% of the numbers in a data set are less than 44.9. All right, so it's a running total of your relative frequencies. And by the time we get to our last class, that means the cumulative relative frequency has to be 1. It has to be 100%. We've included every number in the data set. All right, 100% of the numbers are less than 64.1. And we know that for sure because the largest number in the data set is 64. We could do the same thing with frequencies, by the way. We could say cumulative frequencies. So we have a running total of frequencies. So 14 is the number of numbers in class 1. Since there's 13 in class 2, there are 27 in classes 1 plus class 2. So we would say there are 27 of the 45 numbers that are less than 38.5. And then we keep adding the frequencies to our running total to get the cumulative frequencies. Obviously, when we get to class number 6, we now have all 45 numbers that are less than 64.1. Okay, so this is a frequency. This is frequency distribution table, which includes not only the frequencies for each class, but I've also included the relative frequencies, the cumulative relative frequencies, and the cumulative frequencies. This is pretty much all that you need to know. One thing I could ask also from a table like this, I could say, how many numbers are bigger than 32.1, but smaller, excuse me, at least 32.1, but smaller than 51.3? Well, that would be all the numbers that are in between in classes 2, 3, and 4, these 3 classes. So it would be, how many numbers? Well, we would add them up. We could add them up. 20 would be 24 numbers. Or how would we get 24? It would be all the numbers that are less than 51.3 minus all the numbers that are less than 32.1, which is 14. 38 minus 14 is also 24. So we can use these relative frequencies also, cumulative frequencies also to answer that question. What I also have on this PDF is some information about this, this table. Now, one of the topics that's in section 3.3 is on the couple things on the shape of the distribution. There are 3 shapes, general shapes that we can look at. What are those general shapes? We can have symmetrical, We can have skewed either left or skewed right. Now, let me explain skewness in a second. What symmetrical means is that if you drew a line down the middle of the chart, the left side and the right side would be mirror images. And a bell-shaped curve is the type of thing that we'll be talking about later that is symmetric. But a square would be symmetric. A circle would be symmetric. Okay. Now, we would call this particular histogram skewed to the right. Now, most people get this backwards. They see most of the data is on the left and they call it skewed left. It's not what skewed means. Skewed means is where it's tailing off. It's where the tail is. And if you could picture drawing a curve around this, it's tailing off to the right. This is called skewed right. It's also positively skewed. The word positive, just think of it as moving in the positive direction along the number line, bigger and bigger numbers. All right. So skewed to the right and positively skewed mean the same thing. Now, it's not always true, but I would say almost always true, that the mean is bigger than the median for a data set that's skewed to the right or positively skewed. Now, why is that true? The median, if you ordered your data set from the smallest to the largest, the median is the number in the middle. So in an ordered data set, the number in the middle is the median. Now the median, if you have an odd number of numbers in your data set, in this case there are 45 numbers in your data set, it's literally the number in the middle. How do we know which position in an ordered data set it's in? We would take the sample size 45 and add 1 and divide by 2. So when we add 1 to 45, we get 46. Divide by 2, we get 23. So it's the 23rd number in the data set when we order it from smallest to largest. And it happens to be 36. Okay. Now I use Q2 here. If you remember when we looked at one variable statistics, it actually had MED, but people sometimes call it Q2. So remember, Q2, remember, is also the median. If you probably don't remember, when we were in one variable statistics, the X bar, or the sample mean, was 38.8778. I rounded the 4 decimal point. Notice the mean is bigger than the median. So it's not always true, but mostly true, that the mean is bigger than the median for a data set that's skewed to the right. Now, what is also true about this data set? Well, the sample standard deviation, we already know what it is. We're looking for that S, 10.2014. Again, I will describe what the standard deviation is next time in terms of a formula, but in general, it is the average spread of the data. How spread out is the data? The larger that number is, the more spread out the data is. Q1 is 31.7. Approximately 25% of the data is less than 31.7. Q3 is the upper quartile. So Q1 is first quartile or lower quartile. That's one way of saying it. Q3 is the upper quartile or the third quartile. And it means 75% of the data is less than this number. 75% of the numbers in your data set are smaller than 41.65. We're also going to be learning about next time. I think we're going to get into this beginning of next time. We're going to learn what's called IQR. IQR means interquartile range. It's the difference. We take the Q3, we subtract the Q1, and it leaves, in this case, 41.65 minus 31.7, 9.95. This is another measure of the variability or how spread out the data is. And again, when we talk about box plots next time, we're going to be using this concept of IQR, interquartile range. Okay. Now, a couple things I want to mention to you, and I'll show a demonstration of this next time. The mean can be affected by what are called outliers. Outliers are unusually small, are unusually large numbers in the data set. Let me give you an example of how the mean is sensitive or can be affected by outliers. Suppose there are 5 people in McDonald's, all right? Let's assume the pandemic's over, we're all able to go to restaurants and sit without masks, and hopefully that day will come soon. Suppose 5 people are in McDonald's, they're all working people. And suppose you were doing a survey and you asked all 5 people, what is your average annual income? And suppose you asked all 5 people, they were all around 20, 30, 40, 50,000, all right? And suppose the average was about $40,000 per year. Suppose one person walks out, let's say the person with the highest income, let's say somebody had an income of 50,000, and Warren Buffett walks in. Now, I don't know if you know who Warren Buffett is, but he's one of the richest people in the world. Suppose Warren Buffett loves McDonald's. You would never know Warren Buffett's one of the richest people in the world because he just walks into restaurants. He looks like everybody else, and he drives a used car. So he never wants, unless you happen to recognize him, you would never know. But he's a multi-billionaire. And suppose you walked up to him and you didn't know who he was, and you asked, what was your average income of last year? And Warren Buffett thinks for a minute and he says, $2 billion. Now, at first you start laughing, thinking he's joking, but then he tells you he's Warren Buffett. And he did earn $2 billion last year. That was just his earnings, okay? Well, what do you think happens to the mean? You know, everybody else in the restaurant has a annual income around 40,000, and Warren Buffett has income of $2 billion. Well, if you add those 5 numbers up, those income numbers, and divide by 5, obviously you're going to get a number that's in the billions, and it doesn't make any sense for it being an average, right? The average is totally wrong in terms of those other 4 people, right? It doesn't represent them. It doesn't even represent Warren Buffett very well. But so the mean is affected by outliers, all right? You can see that by this case. The median, however, is not, all right? Again, let's say the median salary of those 5 original people was about $42,000 per year, median salary. When Warren Buffett, the person with the largest salary walked out, and Warren Buffett walked in, and you order those salaries, it still would be 42,000 because that person who's the median is still in McDonald's. He's still in the restaurant. And the median was not affected at all by Warren Buffett being in the restaurant. So the middle value, is not affected by outliers. So that's why when we have a case like this, where we look at this particular histogram and it's skewed to the right or positively skewed, we can understand now why the mean is bigger than the median, because these larger numbers that are out here that are tailing to the right are making the mean larger but are not affecting the median. The median is the same, all right, no matter what these larger values are. So the mean gets larger because of these larger values, but the median does not change. And this is typically an exam question in your final exam. So you may want to make note of this. Take notes about this right this second. That when you are positively skewed, the mean is bigger than the median. And it's because the mean is affected by the bigger values and the median is not. All right. Now, picture the reverse. Picture the reverse here, where this chart, where most of the biggest rectangles are to the right, and it tails to the left, where the smaller ones are at the smallest heights of the rectangles. Picture the opposite of this. That's called skewed to the left, or negatively skewed, where we're going in the negative direction. And in that case, the mean is smaller than the median because the smaller values are making the mean smaller, but the smaller values, again, are not affecting the median. The median is resistant to outliers. The mean is not. So when we have skewness to the left or negatively skewed, the mean is less than the median. All right. Now you should read your textbook, because in section 3.3, they go over this. The mean is less than the median. Okay. And the reason is because the mean is affected by the small numbers, but the median is not. Make a note of that. Study it for your final exam. You'll get a good score in your final, at least in that part problem, if you remember that. And for a symmetrical, like a bell-shaped type example, we'll see examples like that of a histogram. The mean is approximately equal to the median. All right. And we don't see much of a difference between the mean and median. They're approximately the same. All right. So I've actually started to go into chapter 4 while doing chapter 3. Section 3.3. Section 3.4 we'll be doing later, which is section on scatter plots. We're going to be dealing with that when we go into chapter 5. All right. And what we're going to cover next time, we're going to catch up a little bit. We're going to talk more about mean and median, although I think I've covered it quite a bit, but we'll see the formulas for it. We're also going to be talking about standard deviation, an important concept. We're going to look at the formulas for that. We're also going to be looking at these quartiles, Q1, Q2, Q3, and we're going to be looking at box plots. All right, we're going to be doing all that next time, so make sure you're all ready to go. Have your calculator all ready to go, and we'll be talking all about all those things on Wednesday. After Wednesday, I will be assigning some homework, which you'll do over the weekend, which would be good practice for the next quiz and for test number 1. All right, so things that we covered in chapter 3, things that we've covered in chapter 4, I'll be assigning homework for all of that. All right, and it'll be part of your grade, overall grade. Any questions? So I think we're just about done. Looks like it's almost 1:45. I'll stop sharing here. If there's no questions, I'll stop the recording.